A centralized solution for secrets management serves the purposes of the security organization, but only if it can meet the the demands and the volume of requests that come in from application teams and can service those requests expeditiously. So we've seen a lot of focus in our customer base around operationalization of our secrets management solutions, and this has now come into a kind of framework that we're collaborating with our system integrator partners and enabling our professional services team to deliver. So to do this at scale requires a certain amount of automation and delegation, but we don't want the situation where every development team or every application team has their own vault. We want one vault. We want that vault to be managed by the security organization, but we need to be able to quickly grant appropriate access for application developers. And this is the root of a lot of the concern that development teams have in the first place when they consider giving up the vault that or whatever solution they're currently using. So we look. This couldn't be more important now, especially as we look at the new attack vectors like supply chain attacks, where malware is being added to applications and then distributed through trusted means from vendors. So this was the way the SolarWinds breach happened. The CI/CD toolchain was compromised early on, and that's where secrets management can start to help by securing those identities and making sure that that correct processes are being used, and these very privileged automation solutions are authenticated and their access authorized and audited. Then, of course, the escalation. This is where your more classic security tools and privileged access can help to prevent lateral access, and good monitoring always helps too. So secrets management is just part of a portfolio of capabilities. But again, when we're starting to talk about changing the way developers work and doing this, there are certain things that they expect to be provided, especially in terms of quick turnaround. But the number of identities that we're talking about, again, just dwarfs the number of human identities. Humans come and go at a much less frequent rate. Their identities come and go from the network at a much less frequent rate than non-human identities. And the number of non-human identities greatly dwarfs the number of human identities. So a greater number and a much greater rate of change just means that this has to be an automated solution that can scale. So the objectives that we have is, number one, autonomy. We want to enable as much autonomy to the end users, to the developers and consumers of secrets as possible. We want to ensure that they're able to be productive, they're able to get their work done without sitting around and waiting for the security team to grant access to whatever they need. And to some degree, we'll want to be able to delegate some administration responsibilities to those application teams as much as is feasible within security objectives. We want the solution to be efficient, automated mostly. Some approvals might have to be done by people, but in general, we want people out of the loop as much as possible. We want a self-service model, much like what you have with the cloud, where people can more or less provision their own access with some degree of governance and oversight. It needs to be secure, scalable, expeditious, low maintenance, all these things that just make it feasible to use in an enterprise and at scale. And then, of course, separation of roles. We don't allow people to approve their own requests, for example. The security team needs to be in the loop in terms of creating some resources, but then able to delegate some of that to the application team. So being clear about which role is responsible for what and where we can be flexible in those role assignments, it comes into just why this isn't a product, it is a program. It is something that is going to be different for every organization. In general, though, the workflow is going to be a project or an application team is going to submit an access request. That request will be approved. It may be auto-approved, but it still goes through an approval process. It gets provisioned or processed. The results are sent back to the project, and then information captured for governance can also be used here to start anticipating the day where attestations and certifications for application identities may become a reality. But by solving for the self-service aspect of this, we can also set ourselves up for application identity governance. We think that's a very powerful message to be sending, and certainly a very powerful security posture to take if you really know what your application identities are, what they have access to, what they've been doing, and are able to show those controls, grant and revoke things very, very efficiently. So the separation of concerns typically falls to the security team is managing the vault, and they are generally managing the life cycle of secrets in the vault. And the project teams or project administrator can be delegated the responsibility for creating identities and permissions on resources managed in the vault. So the resources that we're talking about are access to credentials that then give access to target systems, target resources here. So it's a little bit of indirection here, but by granting access to secrets, we're granting access to these target systems. And we can delegate that to the project teams. In general, we want the application developers to be as much out of the loop as possible, to not have to know what secrets they need, or at least not have to be asking for requests for this. They can simply get on with doing their work, or at least have a rapid turnaround if they do have a request, have that be very quickly and efficiently provisioned. But this starts getting at those separation of roles and responsibilities. Also, it's important to point out that not every secret has to be under management in the vault. The lower environments, low-risk environments, don't necessarily need their database credentials vaulted. If this is a test database and all that's in there is test data, a MySQL database running on somebody's laptop, that doesn't necessarily need to be vaulted. So these early-stage environments, these low-risk environments, could have their access auto-approved, auto-provisioned. You can even delegate management of secrets to those teams. But as you get closer to production, we would say those secrets need to get vaulted. The changes in access need to be approved, even to the point of going through a change advisory board, certainly for production access. A new application coming into production that is being granted access to a database, that should certainly be under review. And so this is where, we have some flexibility in terms of, according to company policy, whether or not approvals have to actually be done by a person, and whether provisioning can be fully automated and that workflow accelerated. So some of the guidelines that we've established, and we believe these to be pretty well invariant, is that almost all of your secrets access for human, or for non-human certainly, is going to be read-only. The only thing really changing those secrets is going to be some administrative process. It's going to be changed in the core vault and then distributed through the various access mechanisms that we provide. A project is simply a group of related humans, their processes, their resources. This is a way of grouping access together, and typically, we're going to expect that there is an administrative role within this organization to whom elevated privileges can be granted, such as being able to access an administrative vault in the core vault, or being able to create new identities and permissions on those identities, for example. So not every developer is going to be an admin in the project, but typically every project is going to have an admin person or process acting in that administrative role. Vault safes, though, we would say are always and only ever created by the security team, by the vault administration team. And that's simply because safes are the unit of access in CyberArk. And so the ability to create a safe and then start creating accounts and provisioning access to those accounts is something that we want to keep the beginning of that process, the safe creation process, solely within the security team. But access to those safes could be delegated, and that's where we can start relaxing a little bit and say, well, maybe the project admin could have the ability to create accounts in that safe. They can't create the safe, but we can give them a safe that they can create accounts in. And so, again, this starts to hint at the differences in organizations. We've seen basically three models work here. One where security owns the entire process, where they're provisioning the safe. They can create an admin safe to give an administrator access to, store API keys and certs there, but basically all of this gets provisioned by the security team. The developers or the project team gets a list of their identities and the secrets that they have, that those identities have access to. So there's really nothing for the project team to do except request the access. We've seen collaborative models. We've helped organizations build where the security team creates the safes and the accounts in the core vault, but then the project team can create their own identities and permissions. And then we've seen a whole other model where the security team only creates the safe, and the project team can create their accounts in the safe, as well as their identities and permissions on those secrets. And so this is just 3 different models that we've seen work, and just, it's going to be vary, if not by organization, possibly even by project team. Different teams are going to want to work different ways. Some examples from our own customer install base. One is, this is a security-owned workflow, bigger insurance organization that has a fully security-owned workflow where the developer and the project team can fill out an access request in ServiceNow. ServiceNow is typically the front end for this process. More often than not, ServiceNow is the way a ticket is opened and communicated that a project team is going to need access to some resources. Typically goes through an approval process. In this case, the project owner and the InfoSec team can approve this or reject that process or that request. But if it gets approved, then it goes into an automated process that creates the safes, creates the accounts, provisions the identities and the permissions on those secrets, and the developer gets back an email saying, here's your identities and their names, and here's the names of your secrets. And so they can just get to work and start using those identities to access their secrets. So that's one example. That's a security-owned workflow. We've seen another where one of our professional services or system integrator partners was provided this diagram showing a ServiceNow front end where app teams can request access to secrets. It goes through a build and a validation layer, approvals, but then eventually winds up provisioning that access for CI/CD tools to use, and the application teams interact directly with CyberArk for that. So you see that these are the 3 common players that we see in these architectures. ServiceNow as a front end. Typically, the ServiceNow configuration management database is the authoritative source for applications, because basically there isn't another one out there. Active Directory doesn't work for this. So this is basically the definition of an application identity. And then these solutions here are showing what those application identities can access, or controlling what they can access. And so that there's a lot under the covers going into this, some of which we'll see in the demo. Another example, and this is something that we built, that CyberArk Professional Services helped an organization build, had auto-approved or manually approved processes that were fulfilled with a Jenkins workflow. So the automation engine was Jenkins, which then did the provisioning and granted access to an application for its access. And then yet another large bank, that example that a customer built, was their own self-service portal for accessing requests, again front-ended by ServiceNow, with using the ServiceNow configuration management database as the authoritative source. And this is just some of their flows and some of their assets. And in this case, they have a vault per environment. So each environment is fully disjoint from the other environment. So they have the same automated workflow for each environment, but an identity granted access to this vault has 0 access to any of these other vaults, and vice versa. So they have their environments fully isolated, and that's a way of ensuring that they're fully separated, and some examples of their workflows. So really just making the point that this is something that we are getting very good at helping our customers build, and we're working with our system integrator partners to actually come up with frameworks for this, so that it's not a novel exercise for every engagement. And that brings us to the demo and showing it. So I don't have ServiceNow, I don't have SailPoint in this. This is really just showing the art of the possible around the core CyberArk assets of the core vault and Conjur, but it starts to give a sense of what's possible. So in this demo, there's 4 roles, and they're basically color-coded. So there's the project administrator role here. This is the person who can create effectively a new project identity or onboard a new project, because you can't request access for a project that doesn't exist yet. And so In this environment, we have the ability to onboard a new project. If, in this example, the project that we're going to use in the demo is called user 1. If I try and create a project that already exists, it doesn't let me. So it has to, the name has to be unique. This is how we create a new project. Also, we're saying this administrator has to have an identity or an account, has to be an EPV user. And so if I say, just something like J Hunt here, which is my login, there's no user named that. But there is a user named test admin 1. And so I could call them that. So we're saying that the administrator for this project has to be an EPV user, has to be a CyberArk user in order to have access, administrative access to some of the safes that we would create for this project in CyberArk, in core CyberArk. Now, one of those safes is where we would store API keys, certificates, things that would not be synchronized to Conjur or otherwise accessible by applications, but that are credentials that need to be distributed by a trusted intermediary like the project administrator. So we can create API keys, we can store them in that vault, and then the administrator can distribute those to developers who might need those. So in the developer role, which is green, the scenario that I've been using is I'm a test developer. I'm testing a pet clinic application's ability to track the COVID vaccination status of pet owners. And so I would need access to the pet clinic, the pet clinic safe, the test safe. And so what I'm going to do is submit an access request for that. So bring up my access request here. I'm going to say I'm in user 1. This is a project that exists. If I say a project that doesn't exist, like user 2, then it tells me, nope, you got this. This has to be an existing project. So in user 1, I'm going to ask for pet clinic test. And if I say pet clinic test 1 or something that doesn't exist, again, we're doing some validation here and saying this has to be an existing safe. So the idea here is this is an existing project asking for access to an existing safe for either a new or existing identity. In this case, it's actually an existing identity. This identity lives over here. It's called user 1 app example sidecar. We can see that it's set up for Kubernetes authentication, but it doesn't have currently any access to any safes. So I'm going to request, this is just me, I'm going to request this for the test environment for app example sidecar. And so now we see I'm in my space here. I'm requesting this access. That's going to go into an access request that can then be approved and provisioned by a security admin or whatever approval process a customer might have. And typically, once approved, it would just be provisioned. So we've got a two-step process here. Typically, that would be one step, and that is it gets approved and then it gets provisioned. So now we see that this is showing that it's provisioned. Let's see if that's actually true. Well, we go over here, have to re-authenticate. And we're going to look at my host for app example sidecar, and we see that it now has access to the pet clinic test access for this database. So now I can go here, I can deploy my app. I'm going to generate the YAML here. We see that in the app config map here that it's going to access these secrets. So these secrets line up here in this config map. When I deploy the application, there's a script in there that will connect to the database using these environment variables. So it will simply get the environment variable, get the current value, retrieve this secret, and use that to connect to the database using these retrieved credentials. So if I exec into that pod and run my MySQL REST script, it's using a REST call to retrieve those secrets. And now I've connected to the Pet Clinic database as test user 1 using that password. We can see this is a database that's running in my local Kubernetes cluster. And if I do a describe on the owners table, then we see that there's first name, last name, address, but there's nothing about the COVID vaccination status here. So, so this is presumably why my testing isn't working, because there is nothing in the database that's tracking this. I suspect that there was a change made to the schema for the owners table that did not get promoted from dev into test. I'd like to test this theory, but I don't currently have access to the pet clinic dev database. So I'm going to ask for that. So I'm going to go out here, I'm going to delete this deployment. I'm not going to delete my YAML, and I'm going to make a request for access to the pet clinic dev environment, or actually the pet clinic dev database. So I'm going to say I'm in project user 1. The safe I'm going to asking for now is pet clinic dev. Checks to make sure that's an existing database. Now I'm going to say this is the development environment, and what that means is, at least in this demo, that it's going to auto-approve and auto-provision that. So when I click submit, it actually approves it and provisions it, and so I get near immediate access to the pet clinic dev environment. So all I have to do now is edit my config map to say I don't want test here, I want dev. I'm just swapping that out. So the only difference there is that last bit. Redeploy my application, and I go into the pod and run my script. It looks just a little bit different. First off, we see the user is different, the password is different, and now we see that this is actually running up in Azure. This is a completely different database in a completely different space in the development space. I'm connecting to it as a different user, and if I say describe the owners table here, then we see, well, here's the COVID vaccinated Boolean status. This is presumably why the tests are failing in the test environment, why they worked in development. I can fill out my bug report, and now all is good. So a couple of other things around that. One is, we quickly provisioned access for an existing identity, but there were controls around this. It had to be a project that was already onboarded. It had to be for an existing safe, and at least for development, it had to be a low-risk environment. And so for that we could auto-approve, auto-provision. What I also want to show you, though, is, and we see over here that we've got a couple of different safes. So this is where approvals happen. This is where the current status of approvals are. This is where I can revoke access if I want to. Before I do that, though, let me show you something else. So this is actionable. This is the security admin's view into access requests and current status. But there's a fourth role here for the auditor, where if we refresh this now, we can say, okay, the user one project has this identity that now has access to 2 different databases as 2 different users. So here's where we're seeing something like what you would see in SailPoint, where now we're saying these are the identities and their access, and in a fully realized world, we would actually see what this user's permissions were, what its privileges were in this database. And so this starts to get at that governance aspect, where we're just simply reviewing whether there's access that's appropriate here. We could flag things, this could bring our attention to something that's inappropriate. But it is also live in that if I say, okay, testing's done, you don't need access, or your access to dev, you've figured out what it is, you don't need access anymore. We're going to revoke that access. So now we see that it's revoked here. We go back and refresh our view over here. We see that access is no longer there. And certainly in the developer's environment, the developer no longer has access to that. So if I exit here and try and reconnect, I don't have the access to those credentials to connect to that database anymore. So this starts to get at the art of the possible. This is really just showing what we've implemented for different customers for automating and controlling the access for the innumerable application identities that are out there, helping get control and governance around their applications. The solution to enabling this, vaulting the secrets, retrieving the secrets, doing all of that, that's certainly core and important, and certainly from a developer's day-to-day, that's going to be very important. But for this solution to scale and to really show value to the organization, it needs to be efficient, to minimize the number of code changes, be consistent with that sort of self-service model that people have gotten used to with the cloud user experience, and really separate the concerns from the developer and DevOps teams and the security teams. Don't put the responsibility for security on the developers, but also enable fast and efficient workflows that meet the organization's security compliance requirements. That's our demo and our presentation.